This video will cover z-scores. Z-scores, sometimes called the standard score, represents the number of standard deviations a given value x falls from the mean in a distribution of a dataset. The sign of the z-score, positive or negative, signifies whether the score is above the mean or below the mean. The numerical value of the z-score specifies the difference from the mean by counting the number of standard deviations between x, the data value, and the mean. The purpose is to describe the exact location of a score within a distribution. The advantage of using a z-score is that it makes it possible to compare different scores or different individuals even though they may come from completely different distributions. Z-scores tell us how many standard deviations the original observation or data value falls away from the mean and in which direction. We must know the mean, which is denoted by the Greek symbol mu. We must also know the standard deviation, which is denoted by the Greek symbol sigma, and at least one value x from the dataset. When we compute the z-score, we will use the formula z is equal to x, the data value, minus the mean divided by the standard deviation. Z-score distribution is a standardized distribution composed of scores that have been transformed to create predetermined values for mu and sigma. They are used to make dissimilar distributions comparable. Comparing values of x from different datasets will be like trying to compare apples to oranges. The z-score standardized distribution allows for a common denominator of the datasets being compared. Again, z-score distribution is a standardized distribution where mu is equal to 0 and sigma is equal to 1. Here are some pictorial representations of the standardized z-score distribution. Now, the numbers around the curve and underneath the curve should look familiar. Remember from a previous lesson, you learned about the empirical rule. These numbers represent the percentage of data that fall within specific ranges. However, for now, we will ignore these numbers and focus only on the information along the x-axis of both graphs. After analyzing both graphs, we can see that the z-score can be negative, positive, or 0. If z is negative, then the x value is below the mean. For example, if the z value is negative 1, that means the x value is 1 standard deviation below the mean. Same goes for a z value of negative 2 and a z value of negative 3. A z value of negative 2 would mean an x value, which is 2 standard deviations below the mean. A z value of negative 3 would mean an x value of 3 standard deviations below the mean. If z is positive, then the x value is above the mean. For example, 1 standard deviation above the mean means that the z value is equal to 1. 2 standard deviations above the mean is for a z-score of 2. A z-score of 3, you guessed it, means 3 standard deviations above the mean. If z is equal to 0, then the x value is equal to the mean. Let's practice. Let's find the z-score in this word problem. Our word problem tells us that Tanya scores a 1318 on the SAT with a mean score of 1026 and a standard deviation of 209. Jermaine scores a 27 on the ACT with a mean score of 20.8 and a standard deviation of 4.8. Assuming that both tests measure the same thing, who actually has the higher score? Using z-scores can help us determine that. We use our formula z is equal to x minus the mean divided by the standard deviation. Here's what we find when we compute Tanya's z-score. We take her score 1318, subtract the mean score 1026, divide that number by 209 standard deviation, and we get 1.4. Tanya's score of 1318 is 1.4 standard deviations above the mean score, meaning she has a z-score of 1.4. Now, let's compute Jermaine's z-score. We take Jermaine's score of 27 on the ACT, subtract the mean score of 20.8, divide that number by the standard deviation of 4.8, and we get a z-score of 1.29. We can tell now that we have a common denominator that Tanya actually scored higher. And that is because her z-score is 1.4 standard deviations above the average score, whereas Jermaine's score is only 1.29 standard deviations above the mean. Congrats! Now you have just learned the significance of the z-score. You are able to compute the z-score of an x value as well as compare it to the x value of another distributions dataset. For more information on z-scores, visit these two websites. Complete practice problems on pages 102 and 103. Remember, practice makes permanent, so practice correctly.